Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. So today we are going to look at Calculus 1 and our main topic is on the basic differentiation rules. In particular, we are going to look at the chain rule of differentiation. So what does this rule state? So let us write the statement of this rule. We say if y is a function, if y is a function of u, where u is also a function of x, let's say if y is a function of u and u is a function of x, then dy dx is given by dy du times du dx. Y depends on u and u depends on x. This one means that, let me write it explicitly, that y depends on u and u depends on x. Y is a function of u and u is a function of x. And you see the task is to find dy over dx. So that means you need to multiply the two derivatives, dy over du times du over dx. So this is what you're calling the chain rule of differentiation. So when do we apply chain rule? So this rule is applicable when differentiating a function of another function. So that means when you have a function of another function, just like in this case, y is a function of u and u is a function of x. So there's no derivation for this rule. We simply apply the formula to solve these problems. So examples, you're asked to find dy over dx given that in part A, you're told that y is equals to 3x plus 4, and this is raised to 5. In part B, you're given y is equals to, let's say, 1 minus 3x squared, 1 minus 3x squared raised to negative 2, and another one, part C, you're given y is equals to, let's say it is 1 plus 2x, everything over 1 plus x, 1 plus x, and this is cubed. And we can have another one, but part D, y is equals to the square root of x plus root x. So let's see how to work out these 4 problems using the chain rule of differentiation. You can write solution in part A. Solution in part A, we are going to say let u to be equal to 3x plus 4. This is u. So you say let u is equals to 3x plus 4. so that our y will now be equal to u raised to 5. So I need to differentiate u with respect to x, differentiate this so that you get du dx, du dx, that is equals to 3. Also differentiate this other one with respect to u, dy du. So dy du, what will it give us? That is, power rule will give us 5 times u raised to 4. So therefore, it means that now dy dx is dy du, but this is y, dy du times du dx. So when we multiply, dy du is 5 u raised to 4, du dx we got 3. So that is the same as 15 u raised to 4. But you have to replace u. Replace u so that you get 15. Instead of u, we are going to write 3x plus 4, and this is raised to 4. You have to replace u so that you get your final answer. So that is part A. I will solve part B in this side. Let's solve part B here. So what are we given in part B? That y is equals to 1 minus 3x squared raised to negative 2. So the whole of this is what we are saying. Let it be u. So you're going to say let u be equal to 1 minus 3x squared, so that y will now be equal to u raised to negative 2. Now differentiate each of them. Let's start by finding du dx here. So du dx, that will give us negative 6x. And what about dy du? Apply power rule here to get dy du to be equal to negative 2 u raised to negative 3. You have to subtract 1 from the power. So now with this one, now we can get dy dx. So therefore, dy dx is equals to dy du times du dx. So our dy du, we found negative 2 u raised to negative 3 times du dx, which is negative 6x. And so this should give you 12x times u raised to negative 3. And I told you, you have to replace u. So this is the same as 12x. Instead of u, we'll write that as 1 minus 3x squared. And this is raised to negative 3, which you can as well write as 12x divided by 1 minus 3x squared, and this is cubed. That is our derivative in part B. Then we now go to part C. Look at what we have in part C. So we'll write here C. Now I'm going to let whatever is in the bracket, let it be u. So here let u be equal to 1 plus 2x over 1 plus x, so that now y will be equal to u raised to 3. That is in part C. So let's differentiate u to get du dx from here. Look at what we are differentiating is a quotient or a rational function where you have to apply quotient rule. So from here, du dx, apply quotient rule. What does it state? That differentiate the numerator. So we'll differentiate numerator, that is 2, keeping denominator constant, that is 1 plus x, that is a constant. Then now minus, numerator is constant, 1 plus 2x is a constant. Differentiate denominator, we are going to get 1. Everything over denominator squared. So that is 1 plus x, and this is supposed to be squared. Remember our quotient rule? When you are differentiating u over v, it was u prime v minus u v prime over v squared. So u prime means derivative of numerator while keeping denominator constant, minus u, that means numerator is now constant, differentiate denominator, then over denominator squared. And this can be simplified to give us, when you simplify, this is the same as 2 plus 2x minus 1 minus 2x, and the whole of that is divided by 1 plus x, this is squared. See, we can simplify 2x minus 2x, so there we have 1. Our answer here is 2 minus 1, that is 1, over 1 plus x, and this is squared. That is du dx. Again, let's differentiate this to get dy dx. So similarly, dy du, a correction there. So you write dy du. That is the same as 3 times u squared. So now we can now use chain rule to find dy dx. So you can now say therefore dy dx is the same as dy du times du dx. So when I substitute dy du, that is 3u squared times what you have found is 1 over 1 plus x, and this is squared, which you can write as 3u squared divided by 1 plus x squared. So remember, you must replace u. So in place of u, we are going to write what we have. Instead of having to write this, let me not write it in this form, because we are still going to multiply. Let me leave it as the way it is. So we need to replace u. Remember, this is 3 times, our u was 1 plus 2x over 1 plus x. This is u squared times 1 over 1 plus x squared. So this you can as well write as 3 into 1 plus 2x squared, everything over 1 plus x, and this is raised to 4. If I apply the laws of indices, you're going to get that one. And that's our derivative in part C. Now let's see how to work out the other part, that is part D. I can take this up. In part D, what are we given? Look at, we are given y is equals to the square root of x plus another root x. So the whole of that will be u. So you're going to say remember this can be written as x plus root x raised to 1 over 2. So now we say let u be equal to x plus root x, so that y will now be equal to u raised to 1 over 2. Very important. Now we differentiate each of those equations. Differentiate this with respect to x, so we get du dx. What will it give us? It will give us 1 plus derivative of root x is the same as 1 over 2 root x. We already did it under power rule. Because root x is the same as x raised to 1 over 2, then apply power rule to differentiate it. You're going to get 1 over 2 root x. What about the other one? Y is equals to u raised to 1 over 2. This will give us dy du to be equal to 1 over 2 times u raised to negative 1 over 2. And so this you can write as 1 over 2 root u. So now we know those respective derivatives. So we can now apply the chain rule to get dy dx. So you can say now, therefore, dy dx is the same as dy du times du dx, of which if you multiply, you get 1 over 2 root u times 1 plus 1 over 2 root x. When you replace u, what do you get? You're going to get this. Where there is u, I write root x plus, no, x plus root x, that is our u. So this is the same as 1 over 2, the square root of u is the same as root of x plus another root x times 1 plus 1 over 2 root x. So that's what we have as our dy dx. And you see, we have used the chain rule of differentiation. Now, I want to give you the simplest method of applying the chain rule without having to say let u is equals to this so that y is equals to this one. It is what we call direct chain rule. So let me write it down here. I'll call it number 7. What you're calling direct chain rule. Call it DR, direct DCR, direct chain rule, DCR. So what does it state? That if y is equals to u of x, and this is raised to n is any real number, then dy dx, you first of all use power rule to differentiate the power. So we'll have n, bring down the power so that we have u, a function of x raised to n minus 1, then times u prime of x. That is what we are calling direct chain rule. So I'll bracket this one. So what happens, you start by differentiating the outermost bracket. Once you get the derivative, you multiply by derivative of the whatever is in the innermost bracket. That is u of x, which is now u prime of x. So I'll give you some examples to illustrate this direct chain rule. So examples: find dy over dx given that in part A, let's work out what we had in part A here. What was it? It was 3x plus 4 raised to 5. I want to illustrate that using direct chain rule. Y is equals to 3x plus 4 raised to 5. In part B, I want to look at the same problem in part B. That was 1 plus 2x over 1 plus x cubed. Well, let me pick this one. Y is equals to 1 plus 2x over 1 plus x, and this is cubed. In part C, pick the same equation that we had in part C. It was, I have changed these ones. The one I've written as part B was part C. In part B, we had 1 minus 3x squared raised to negative 2. So I'll just change the numbering. 1 minus 3x squared raised to negative 2. Just change the numbering here. Instead of this will be part B, and this other one is part C. So this is B, this is C, and part D, y is equals to the square root of x plus root x. I want to do the same using direct chain rule. You see, direct chain is very easy as compared to chain rule. So in part A, we are going to start by differentiating the power, which is 5. So you write dy dx will be equal to, bring down the power, that is 5. Then the power will be less by 1. So 3x plus 4 raised to 4. 5 minus 1 is 4. Then times derivative of 3x plus 4, which is 3. And so the result here is 15. 3x plus 4 raised to 4. That's what we have. What about part B? Part B, we have, we are going to differentiate the power, which is negative 2, so that we now talk of, let me wrap this. We will now talk of dy over dx is equals to, bring down negative 2, so that the resulting power will be less by 1, so that will be negative 3. So 1 minus 3x squared times negative 3. Then now differentiate what is inside the bracket. So times, when you differentiate 1 minus 3x squared, you get negative 6x. And so you can now open the bracket. This should give you 12x times 1 minus 3x squared raised to negative 3. In part C, you start by differentiating the power again. The power there, so you write dy dx is equals to, bring down 3, that is 3. Then the resulting power should be less by 1. So we have 1 plus 2x over 1 plus x. This is now raised to 2 because the power is less by 1 now. Then times derivative of what we have inside, 1 plus 2x over 1 plus x. Now you apply quotient rule. So keep u constant, not u, but you differentiate u, keeping v constant. Remember, this is u, and this is v. So u prime is 2 times our v, which is constant, is 1 plus x, minus now u is constant, 1 plus 2x. Differentiate v, you get 1 over v squared is 1 plus x squared. If you simplify, you are going to get 3 into 1 plus 2x over 1 plus x, this is squared, times, that should give us 1 over, 1 in the numerator, I mean. So I'm going to change that. So times, the numerator is now 1, over denominator 1 plus x squared. When you apply the laws of indices, you're going to get 3 into 1 plus 2x, and this is squared, everything over 1 plus x raised to 4. And lastly, in part D, You see, this can be written as y is equals to x plus root x raised to 1 over 2. So again, we apply direct chain rule to get dy over dx is equals to. Now start by applying power rule. You bring down 1 over 2, then the resulting power should be less by 1, so x plus root x raised to negative 1 over 2. Then the next, we differentiate x plus root x, so times derivative of x plus root x, that is 1 plus 1 over 2 root x. So that is our answer, which you can as well write as 1 over 2 root x plus root x times 1 plus 1 over 2 root x. So you see, we have found the same answers, but in this case, now we have applied direct chain rule, which is easier than chain rule. You see, chain rule, you have to say let u be equal to this, so that y is equals to u raised to something. And then you differentiate u, you also differentiate y, then you multiply those derivatives. But direct chain rule takes you straight away to the answer. Just one line, you get your answer. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at other techniques of differentiation. Bye-bye.